Hi class, today we are on Saxon Book 4, Lesson 54, and we're going to talk about the calendar and rounding numbers to the nearest thousand. So, the first thing we're going to talk about is some information that if you don't already know it, you're going to need to add this to your math dictionary. So, we're going to start with the common year. The common year has how many days? Think about that, shout it out, yell it at your TV screen. How many days are in the common year? If you said 365, you are correct. The common year has 365 days. Now, we have 3 common years, and then we get a leap year. Every 4th year is a leap year. A leap year is when one extra day gets added onto the month of February. February usually has 28 days, and during a leap year, February has 29 days. So if a common year has 365 days, how many days would be in a leap year? Yell it out at the screen. If you said 366, you would be correct. How many years are in a decade? A decade has how many years? One decade equals 10 years. A century, how many years are in a century? A century has 100 years. So I'm going to repeat. If you did not know this information already, pause the video right now and get this stuff in your math notebook. The reason I have you write it down is because the act of writing helps to commit things to your memory. So even if you never look at it again, just by writing it down, you are more likely to remember it the next time somebody asks you how many years are in a decade. So go ahead and do that. And I'm going to erase that information. Okay, if you were in my class last year, or if you used Saxon Math Book 3 last year, in 3rd grade, one of the very first lessons is on the calendar, and they teach you a little poem. It goes like this: 30 days hath September, April, June, and November. All the rest have 31, except February, which has 28 days and 29 each leap year. You can memorize that poem. That will help you remember how many days are in each month. Or several years ago when I was teaching, one of my students taught me this trick. Hold out your knuckles and say the month, starting with this knuckle, and then you stick your finger in the space, the little dent between your knuckles as you say the next month. So I would say it like this: January, then in the dent, February, March on my knuckle, April in the dent, May on my knuckle, June in the dent, July on my knuckle on this hand, and then I say August on my first knuckle on this hand, September in the dent, October on the knuckle, November in the dent, December on the knuckle. So the reason we want to do that is the knuckles kind of raise a little bit on your fists. The knuckles stand for the months that have 31 days. So January, March, May, July, August, October, December. Those months that land on my knuckles all have 31 days. The months that are in the little space between your knuckles only have 30 days, except February, which is also in a space there, so we know it doesn't have 31 days. But February is a special case. You just have to remember 28 days. Unless it's a leap year, then there's 29 days in February. Okay, so our first example says, how many days does December have? You can use the poem or you can use your knuckles, and you're gonna land on this knuckle with December, which means December has 31 days. So for example 2, we're gonna look at this calendar here. This is a calendar from May of 2014, and it says, according to the calendar, May 10th of 2014 is what day of the week? So you should be able to find the 10th, and then you look up here and see it's the last day of the week. It's a Saturday. Calendars are typically written starting with Sunday, ending with Saturday. Occasionally you'll see a calendar that starts with Monday, but the way you know is you look up at the top and they'll have the 7 days of the week labeled up at the very top of the month. All right, our next example. The Pilgrims sailed to America and landed at Cape Cod in the year 1620. The colonies adopted the Declaration of Independence in 1776. It says, write a later minus earlier equals difference equation and solve it to find the number of years between those two historic events. So again, this is a review from last year from book 3. They taught us that when we're trying to find a difference in years, we take the later year, which is always going to be the bigger number. We subtract from it the earlier year, which is always going to be the smaller number, and then we find the difference. So in this case, 6 minus 0 is 6, 7 minus 2 is 5, 7 minus 1 is 1, and 1 minus 1 is nothing. Can I put a 0 there? Sure. Do I have to? No. And typically you don't see that. If you're talking about 156, we're not going to see a 0 in our answer. What we do need to see is the label. Since it's a word problem, we need a label. All right, now we're going to move on to rounding to the nearest thousand. And again, this is kind of a simple lesson because nothing changes except the place value that you're looking at. We round to the nearest thousand the exact same way we round to the nearest 100 and round to the nearest 10. So in this example, we are looking at 7,836. And it wants us to round the number of tickets. In this case, it's a word problem. So 7,836 tickets were sold for the first professional indoor soccer game of the season. Round the number of tickets sold to the nearest 1,000. So this is how many tickets were sold. We want to round it to the nearest 1,000. So this is the place value we're rounding to. In order to make sure that we don't go too low, I want to put it on a number line. Let's start, say, 5,000. Okay, my number line is numbered with every 1,000, 5,000, 6,000, 7,000, 8,000. Where on the number line is this number going to fall? 7,836. Is it going to be between the 5,000 and the 6,000? No. Between the 6,000 and the 7,000? No. Between the 7,000 and the 8,000? Yes. This number is more than 7,000, but it's less than 8,000. So we know that it's going to be somewhere in this section of the number line. So I'm going to split that section in half, and this right here is halfway between 7,000 and 8,000. So what would that value be? Halfway in between would be 7,500. So is 7,836 going to be here in the first half or over here in the second half? If you said over here, you're correct. It will fall probably about right there. 7,836. So then we want to look, which round number is it closest to? 7,836 is much closer to 8,000 than it is to 7,000 over here. So we would round, I'll go this direction because I'm running out of space. We would round to 8,000. All right. Now I want to talk about the same problem without using a number line. There's just a rule. If we're rounding to the nearest 1,000, we know that this is the only digit that's going to remain a digit. The rest of these are going to be zeros. So we have to decide, is this going to stay a 7 or is it going to go up to an 8? So actually, let me give you a different example. Let's just change it a tiny bit. Okay, if I round to the nearest 1,000, the reason I changed this is because that last one's going to round up. And where my students tend to make the biggest mistakes is when you have to round down. Because we say round down, which makes them think we're going to change this digit to a 4. And we will never do that. When you're rounding, you either make the digit one number higher or you leave it the same. What we mean by rounding down is we mean we're getting rid of this 236. 5,000 is a smaller number than 5,236. Okay? So we round down to 5,000. We don't round down to 4,000. Let me write that. Not 4,000. Now, how did I know I round down? This is when we look at the next digit. Whatever place value we're rounding to, we look at the next digit and we follow the rule. If the number is less than 5, we round down to 5,000, not to 4,000. If this digit is more than 5, or if it is 5, we round up, and in that case, we're going to change this to 6,000. So in this case, round down to 5,000. Okay, our next example says, a special exhibit at a museum was seen by 34,186 visitors. To the nearest 1,000, how many visitors saw the exhibit? So this is a pretty big number. The first thing we have to decide is, where's the thousands place? Ones, tens, hundreds, thousands. So this is the number that we're rounding to. So we want to look at the number immediately, the place value immediately before, the number immediately after. But the number to the right is what we're looking at. Okay, so we look here at the 1. This is less than 5, so we're going to round down. Now here's how this works if you have other digits. They stay the same. So I'm not touching my 3. And in this case, since I'm rounding down, I'm not changing my 4 either. And the rest of them become zeros. Okay? Rounding down, we don't change this digit. Only if we round up do we make it a number higher. 34,000 would be our answer. Final example before you guys try some on your own. We are going to round 5,486. We're going to round it to the nearest 1,000, the nearest 100, and the nearest 10. So let's start with the nearest 1,000. 5,486, we look at the digit immediately to the right. 4 is less than 5, so we round down to 5,000. Now, we round to the nearest 100. Look at the digit immediately to the right. 8 is more than 5. So my 5 stays the same. I'm going to round up. So this 4 becomes a 5. And then my other digits are 0. Now we're going to round to the nearest 10. Look at the digit immediately to the right. 6 is more than 5, so we're going to round up. 5 stays the same. 4 stays the same. 8 gets rounded up to 9, and then we have a 0. Okay. For our lesson practice, the first couple problems are calendar problems. So I'm just going to ask them. I would like you to say the answer out loud at home, and then I'll give the answer, and you'll be able to see if you were right. So the first question, how many days are in a leap year? How many days are in a leap year? 366 days. Were you right? Give yourself a pat on the back. Question B. You know what? I'm skipping that because I erased the calendar and I don't want to draw it again. If you would like to do question B, it's on page 347 of your book, and you can look at the calendar that is just one page before that, 345. Okay, let's go down to C. How many years were there from 1918 to 1943? You're going to need a whiteboard or a piece of paper for this one. How many years were there from 1918 to 1943? So you'll need to write an equation and then solve it. When we're trying to find the difference between years, we take the later year and we subtract the earlier year. I can't do that, I'm going to have to borrow. 13 minus 8 is 5. 3 minus 1 is 2. 9 minus 9 is nothing. 1 minus 1 is nothing. So 25 years is my answer. And our final calendar question, a century is how many decades? A century is how many decades? If you don't know, take a look at your math dictionary. You should have these terms in there. A century is 10 decades. 10 years equals a decade. 100 years equals a century. So we count by tens till we get to 100, and we should have 10 decades is equal to 1 century. All right, the next problems, you are going to practice rounding. You are rounding to the nearest 1,000 for every single one of these problems. There's the first one. Okay, round to the nearest 1,000. Hit pause while you work on that. Hit play when you're ready to go over the answers. Okay, I am rounding to my thousands place here. I look at the very next digit. 7 is bigger than 5, so I round up to 7,000. Do that again here. There's my thousands place. 2 is the very next digit. 2 is less than 5, so I round down to 5,000. Now this one, this has a little bit more than thousands, so I have to locate my thousands place. Look at the very next digit. 3 is less than 5, so I round down to 12,000. Ladies and gentlemen, that is the end of this lesson. Now it's time for you to begin your written practice, which is on page 348 of your textbook. I hope you have a wonderful day, and I'll see you soon.